Today we're going to be talking about the fuzz face, what it is, what it does, and how to mod it. Hi there everybody, thank you for joining me. Bit of housekeeping first. If you haven't subscribed, please subscribe and ring the bell icon. You'll get all the good stuff, simples. And also, while you're doing all that button pressing nonsense, head over to Instagram and follow me on Instagram as well. That's where all the daily updates occur. Okay, fuzz face. That. Schematics always seem very daunting when you're starting off on your pedal building journey. They did to me for a long time. I stuck with tag boards. Once you know how to do it, it's like reading music. And once you know, it's so simple. Once you know how it works. So what I'm going to do in this little episode is go over a little bit about schematics, a little bit how that applies to the fuzz face, how the circuit works very generically. I mean, I'm not going to go into massive details, and then go and talk about some modifications that you can do that are straightforward and give you a little bit more flexibility and a more modern approach to the circuit if you want it. Schematics. It's rattly, hang on, bear with. Pedal builder's friend, bear with me. Not rattly. Right, anyway, okay, so schematics. And I did have a pen. Here we go. So there are 3 or 4 basic symbols that you will need to learn, and that's pretty much it. Okay, and I'll just go over those. They're included in the fuzz face circuit, and you'll start to understand. You can then look at schematics and start to begin to understand what is happening. So I'm just going to point out the symbols in here, then we'll go through over how the actual fuzz face works. So this, these stripes, long and short stripes, are battery or power supply, and it'll have the polarity marked and how much it is. So 9 volt, easy. Input jack serves, so you've got one going to ground. This is the to ground symbol, and this is the other one that is the tip of the input jack. Okay, so then that goes to a capacitor. Now you notice there's there's actually 3, but let's look at the 2 capacitors here first of all. You've got one with this curve. This is the sign for a capacitor. It's either 2 straight lines or a straight line and a curve. The difference between the 2 is that the one with the curve is what's known as polarized. It will only allow an audio signal to travel in one direction, whereas this is non-polarized and an audio signal can travel in both directions. And in this position in the schematic, they are acting as what is known as decoupling caps. That basically means that the DC within the circuit, the power within the circuit, won't leak out into the guitar or the amplifier. Now here's a note about types of current in a circuit. Now this took me decades to discover. It doesn't seem to be spoken about very much on the interwebs. DC, your power, and AC, your signal. AC, audio. Okay, alternating current is audio current to me. Anyway, AC can coexist in a circuit without interfering with each other. Well, there are certain points at which they do interfere with each other, but in a well-designed circuit they won't. So they can coexist and use one part of the circuit for 2 completely separate reasons. Okay, blew my mind. So then you can look at a circuit and say, what's the DC doing in this circuit? Right, that's what the DC is doing. What is the AC doing in this circuit? And sometimes the DC and the AC are doing the same thing. They're being amplified. Sometimes they are doing completely separate things. So once you know those things, it starts to make way more sense. Anyway, so these are decoupling caps. Back to the mission in hand. This is the sign for a transistor. We have two transistors here, and every transistor has three legs. Okay, you have a collector, a base, and emitter. Occasionally they are in slightly different order. Sometimes the collector and the base are swapped in, for instance, BC183L, they change around, and a couple of other things. So that's called the pin out. Okay, so if you're not sure, if you've got a transistor and you're not sure what order they go in, just Google BC108 pin out and you'll get diagrams saying what goes where. So that's the symbol for transistors. This here is a resistor. Now, there are two symbols. The more common symbol is in fact that. I don't know why they just put boxes in here, but that's the way that is. Yeah, they're resistors. And they resist current. They slow the current down, or they thin it out, or whatever, however you like to call it. This symbol here is a potentiometer, a pot. So it's a resistor. It's got the resistor symbol. So very often it'll have that, or it'll have the squiggle. Okay, but it also has numbers 3, 2, 1, 2, 3. Okay, they are the lug numbers, and that's the where you connect the lugs to, and that becomes a variable resistor. So it's a resistor that you can adjust. Okay, so with that in mind, you can kind of look at a schematic and go, okay, well, I need these items here. You don't necessarily know what they do, but at least you know what items go where in your layout. Okay, so let's talk about the fuzz face audio path. So the primary audio path in a fuzz face is from the input. It goes through this capacitor, okay, to the base of Q1. This capacitor is a filter capacitor. As I said earlier, it allows the audio through but doesn't let the DC back out. At that 2.2 UF, it is also a frequency filter, but it's not really filtering much frequency. That's a very high rating, so it will let most of the frequencies through. If you lower this, we'll talk about this later in when we talk about mods, but as you lower this, it cuts out more bass. Okay, so it goes to the base of Q1 and then is amplified in Q1 across the junction of base to collector, and then it goes up to this base here. Now it sees some resistance there, so it said, no, I'm not going up there, I'm lazy, I'm going to take the route of least resistance. So it doesn't really go anywhere there, it just heads this way and onto the base of Q2, so it's already slightly amplified. And then again, it is amplified once again from the base to the collector of Q2. It then goes up, is limited slightly. It goes to this junction here, which I'll talk about a little bit later. And because there's a little bit of resistance that way, it goes through this capacitor here, where it's filtered again, and it is the DC is blocked from going out. Goes to volume, you adjust your volume, and it goes to the amplifier or the next stage of your pedal board. So that's the primary audio path. There is also what we'd call a secondary audio path, which is called the feedback loop, which basically there is an element, a reduction of the amplified signal sent out of the emitter down here, okay, to this junction. And it has two ways of going. Let's ignore the fuzz control for the moment, and let's just assume that it is going this way back round. What's that doing? Well, if this was not there, this would be feeding a restricted amount, but a specified amount of the signal back into Q1. So it wouldn't have, so it was getting a stronger signal to Q2. Now it seems counterintuitive, but that actually means that Q1 and Q2 don't have to work as hard, so don't distort, because they are expecting to produce a certain amount of output. I won't go into how they expect it, but they are. So if they don't have enough signal, they will boost it up to that amount, and that's what causes the fuzzy distortion. But if you feed this amount back, it cleans it up. It lowers the volume to a degree, but it also cleans it up. Now, bring in the fuzz control, and if you start bleeding some of this signal to earth, then Q1 and Q2 specifically, have to start working harder to make up the volume, and that's where the fuzz comes in. Now, if you took the feedback control out, the gain would be uncontrollable. So this is a way of controlling the gain to bring it down to those layers of fuzz that we all know. Okay, so generally we are utilizing the minimum. If you've got your fuzz set max and max, okay, max volume, max fuzz, you're utilizing the minimum amount of feedback to keep the fuzz under control. Okay, if you turn it right down, it does go out, but that's just taking it beyond the point of electronic capability. But if you turn the fuzz down to a degree, then you're introducing more of the original signal back, and the transistors don't have to work so hard. Okay, there is also a 20 UF capacitor here. That adds some impedance to the emitter. I won't go into too much detail, but basically that's a filter. So as you turn it down, the EQ it changes. So there are things you can do with that. I probably won't talk about that in the mods, but that just keeps the bass stable. Okay, so that's the audio path basically described. I just want to talk a little bit about the impedance of the fuzz face. I'm not going to go into technical details. It's a really massively confused and confusing principle. The way I try to explain it is that the amplifiers, these are the two amplifiers, they expect and demand a certain quality of signal, and they need a low impedance, which is basically a big open door, unrestricted big open door, so that they can pull the signal out of your pickups. It's called loading your pickups. It pulls the signal. And it gets everything that it needs. Now, if you increase the impedance on the input, it begins to throttle what the amplifiers can pull through. And I equate that to reducing the bit rate of your signal. So basically it just becomes, there's less information coming through. It stretches your audio signal. And the first, as with low bit rate audio files, the bass is the first thing to suffer because that needs the most amount of information to transmit. So you'll find that as your impedance on the input goes up, i.e. you put a say a buffer or something in front of it, the amplifier starts to struggle to pull what it wants. Okay, so that's how I kind of try and describe impedance. It needs an open door, it needs free flowing signal so it can pull as much as it wants and get, you know, all that good stuff. Basically, we've spoken about the amplifier, we talk about the feedback loop. One of the last things I want to talk about is the maximum volume of a fuzz face, which is often some people deride the fact that the fuzz face isn't very loud. Now, there's a reason for that. It was designed not to be very loud. It's not a circuit to push an amplifier, because you do that and you start losing the fuzz. The amplifier starts printing its sonic footprint on your tone and not the fuzz face. So they generally try the fuzz face is kind of set for the input volume to be slightly lower, not much lower than the output volume. Now, the fuzz face is capable of massive hike in volume if you wanted it, but it's not really needed. It doesn't serve the circuit well to be smashing the front of an amp. It needs to go into an amp at unity so that the harmonics and the complex nature of the tone will still show through. So how is that volume attenuated? Because the volume at this point at the collector of Q2 is huge. So we've got this 8.2K resistor. Now here's what I was saying about signal AC and DC can use different parts of the circuit for different things. So this 8.2 resistor here is basically reducing the DC that is getting to this capacitor, reducing the current that is getting to this to around about half the supply. Okay, 9 volts, so 4.5-ish. Can swing it up and down a little bit. But what this is doing to the audio is actually attenuating it in the opposite direction. Now, the 8.2K resistor on its own isn't enough. So we have this 330K, 330 ohm resistor here, which creates what's called as a voltage divider. It divides, again, I won't go into too much detail, but basically it divides the voltage by a ratio set by these, okay, and or the signal, divides the signal, should I say, and that attenuates the volume even further. So this, because it's so small, it doesn't really affect the amount of voltage that's getting through if you change it. Does a tiny little bit, but not a massive amount. But it has a huge contribution towards the rating of the voltage divider for the audio signal. So if you want to change the maximum volume of the pedal, change this Okay, so 330 is a good is a good one for silicon because they are slightly higher output. You can maybe go to 390. 470 is good for germanium, and that sets the maximum volume. Okay, when the volume pot is set to full. Now, the volume pot and the capacitor at the output also create a filter, a high pass filter. And as you increase the high pass filter is a capacitor and a resistor in series. As you increase the rating of the resistor, it changes the filtering frequency. So the reason that you want to set a maximum volume is that it's best that you can actually use the volume pot as a tone to a degree. When this is flat out, it attenuates the lowest frequencies to a degree. So when the volume pot is fully maxed, it feels like there's more treble, but it's actually attenuating the bass frequencies and letting more treble through. And it gives you that really nice saturated upper mids that, you know, that great fuzz faces kind of have. The whole volume scenario here with these three components needs to be very carefully considered, because if it's too high, it will push the front of your amp and it will sound flat. You don't want it to push your front. You still want it to sound dynamic. A fuzz face should still feel dynamic when it's flat out. So these three components have a huge impact on the volume and the tone at any given setting. So modifications, input and output caps. What's the difference between changing your input cap and changing the output cap? Okay, so the input cap, you're changing this, it allows more or less bass into the circuit. And changing the output cap changes how much bass it goes out of the circuit. So what's the difference? Why can't I just change one or the other? Will it make a difference? Yes. The more bass you allow into the circuit, the more signal you're giving the circuit, so the more it will saturate. So it's like it's giving it, overloading the amount of information it needs to deal with. And the bass frequencies are the most information heavy frequencies, if you like. So as you cut down this figure here, say to 1 UF, like in the Analog Man Sun Face, it reduces the bass just a little bit and the saturation and the woolliness. It gives it just that little bit more clarity. And then you go to the 1.5 tone bender and the Vox tone bender and the Vox distortion booster. This is massively reduced and it's a much gnarlier, less woolly, more urgent sounding fuzz straight off the bat. Okay. Whereas changing this output, the output capacitor, will be very much more a change of the tone of the timbre of the circuit. Increase it because there is bass generated within a circuit, so increase that and you will allow more bass out. Decrease it and you will restrict the amount of bass going. Remember, it's also in combination with the volume pot, making that filter that we spoke about earlier on. So if you change this for 100k, it reduces bass further, and by clever kind of combinations of these, you can kind of target the upper mids somewhat, and the Eric Johnson fuzzface, for instance, has a 100k pot here because it reduces the bass but kind of still keeps the upper mids intact. So another mod that is very, very popular is a bias mod. So what's biasing all about? These resistors rely on getting a very specific voltage through to them to work within quite a tight operating range. These are the two biasing transistors. They basically hang off the collector on both transistors. This resistor can have an effect on the circuit, but not really one that is either musical or dramatic. So biasing this resistor here on Q2, the Q2 collector resistor, is generally in probably 80% of the pedals, when you see a bias adjustment, that is what they're adjusting. So how does it work? Well, basically, what generally happens is this resistor is reduced somewhat to maybe 2 or 3k, and then anything upwards of that is put on a pot, a 10 or 20k pot, and so you can adjust it all the way down to 2 or 3k, whatever the setting is you put in. And what that does is that allows the voltage to be manually fluctuated at the collector. So that's another modification that you can put in. So that would actually go in. So you'd put that in there like that. A 10k pot in there, and reduce that to maybe 2k or something like that, and then you have a nice swing of voltage that you can change to the Q2. They're the kind of, you know, the stock mods that you can do. Then you get to things like changing the feedback resistor for more or less fuzz at maximum, looking at changing this resistor here for a little bit more volume. So playing around with the resistor values up or down a little bit just to see what suits. If you are new to pedal building and building fuzz faces in particular, my advice would be to start with the stock values, build something that works and you feel is you know, good and a usable fuzz before going on to make your mods. Don't try and start off building a modded fuzz face, because you don't know what works and what doesn't really. So build stock values. They're all just Google the fuzz face schematic, pull this one up, and there's a GE version as well, and you will follow this to the letter and you'll have a fuzz face. It's simple as that. 9 components. 9. That's that. I hope that has been insightful for you and has given you some food for thought. It's a world of discovery going into the fuzz face, so good luck. If you have any comments, if you have any questions, if you have any disagreements, feel free to drop them down in the comment section down there. And once again, please subscribe, hit the bell icon, and have a great day. Have a great weekend. My name's Marcus. This is Roots Electro. You've been watching the Friday Finish. And remember, keep it fuzzy.